Hello and welcome to this Feedinfo webcast where we will be discussing how to employ enzymes in monogastrics to effectively navigate the feed raw material price and availability challenges that the industry is experiencing right now. I am Monet Brunt. I am the Perspectives content editor here at Feedinfo, and I will be your moderator for this webcast. Today's session was developed with our friends at Cargill Animal Nutrition and BASF, who have formed a global partnership to deliver enzyme-based solutions that generate value for the animal feed industry, and we thank them for their support. Firstly, I would like to explain how the session will work if you have not seen a Feedinfo webcast before. We have pre-recorded the session, but our speakers are online right now to take questions in the questions tab, which you can find on the bottom right-hand side of the screen. If you post a question in the questions tab, they will also be able to type your response, so please ask away throughout the webcast. We will also be releasing a number of polls throughout the webcast, so if you want to share your opinions and see what others in the industry are thinking, please do participate in these in the polls tab, which you can also find on the bottom right-hand side of the screen. So with that bit of housekeeping done, I would like to quickly introduce our speakers who will be sharing their expertise with us today on how enzymes can deliver some real relief for feed makers and feed users amid current raw material uncertainties that we're seeing. So we have with us today Dr. Everton Krab, head of the Pork and Poultry Unit of the Brazilian Agricultural Research Corporation. We also have Dr. Guilherme Pascali, Global Technical Product Manager for Feed Enzymes at BASF Animal Nutrition. And finally, Dr. Rob Payne, Director of Poultry Nutrition and Technical Services for Cargill Animal Nutrition North America. We're also doing things a bit differently this session because you will also be hearing from a few industry professionals throughout who have pre-submitted questions for our panelists. So do keep an eye out for those. So before we jump in, I would just like to go around and ask our speakers to properly introduce themselves and tell us a bit more about what it is that they do. Everton, can I start with you, please?
Hello, everybody. Yes, it's a pleasure being here with you and sharing some ideas about enzyme use and how to overcome this bad scenario of high cost of raw materials. I have been working with animal nutrition for almost 30 years, swine and poultry especially, and we never saw scenario like we're seeing right now with such high cost of raw materials. And obviously, under those conditions, we have to use technical tools like enzymes. And enzymes has been a subject for us in our research center for more than 15 years, maybe 20 years already. And we have been working with many different enzymes, especially phytase, long time ago, and more recently with other enzyme activities or compounds like multi-enzymes and especially NSP combined with phytase and manganase, protease, amylase. So there's a lot of things to share with you.
And Guilherme, can you tell us a bit more about yourself, please?
Yeah. Good morning, good afternoon, everyone. First, it's a pleasure to be here, and I'm excited about the opportunity to talk about feed enzymes, especially during times of high feed prices. I've been in the industry for much less time than you, Everton, but from my background, I completed my studies in animal science with focus on animal nutrition. And after working for two premix companies as a poultry nutritionist, I joined the BASF animal nutrition team as a global technical product manager responsible for the xylanase and the beta-glucanase. I've been involved with feed enzymes since I was a student, and this is something that I really enjoy doing, so I'm looking forward to this conversation today.
And finally, Rob, over to you. Can you please tell us a bit more about yourself?
Sure. Hi, everyone. Thanks for joining today. It's a pleasure to be here. So Rob Payne, as mentioned, I'm the Director of Poultry Nutrition. I'm trained as a non-ruminant nutritionist and not quite as long as Everton in the industry, but closing in on 20 some odd years in the industry, working primarily with swine and poultry, not just here in North America, but around the world, and working with both producers of feed and animals. I've been with Cargill Animal Nutrition now about 3 years, focused on say, the application of enzymes, among other additives, and managing ingredients to ensure animal performance success. Prior to that, I was on with a couple of other groups, designing enzymes, developing enzymes for animal use, as well as going back to my graduate school days of doing some of the first matrix work for phytases here in the US. So pleasure to be with y'all.
Thank you all for that. Clearly, you're all well placed to help us tackle this issue, and I look forward to what you will be sharing with us today. Now, from supply chain fragility and rising global energy prices, there are numerous factors putting strain on the affordability and availability of feed raw materials. So my first question is, considering these concerns, what are some of the biggest challenges this has presented feed producers? Everton, can I start again with you, please?
Okay, you know, feed industry is a huge industry. So the amount of raw materials that are consumed and processed every day is a huge amount. When you face a situation that you have short in raw materials, that is very hard to handle this. And the consequence is obvious, is a price rise automatically. And there are not that many alternatives, because alternatives means as well we have to have this available in huge amounts, which is not a fact. So there is not that much room to move, and we have to find ways to extract as maximum as possible the nutrients out of the standard raw materials that we have so far. Okay, there are some trends, especially in South America, in Brazil mainly, to rise the amount of winter cereals production, for example, but that's not that significant so far, and we basically depending from corn and soybean. That's what we have, and we have been struggling with this shortage, and it's in high cost, and obviously it's time to look to technological tools to improve your feed processing, and all what you can do is to maximize the uptake of the nutrients by the animal. That's it.
Perfect. Is there anything you would like to add, Guillermo?
Yeah, I don't want to repeat, but just to add a quick word on it, I think we've seen that the current geopolitical events have a direct impact on the feed industry and have caused a major shock to the price of raw materials, particularly corn, wheat, and soy, which are the main raw materials used in poultry and pig diets. But there are also other reasons for this increased feed prices, like the poor crop harvest due to climate change, a high demand of raw materials because of the recovery of the global demand for animal protein, an increased demand of feed related to the partial recovery from African swine fever, for instance. And in addition to that, energy costs to process the feed, like pelletize and heat treatment and so on, are rocketing, and this is leading to an explosion in feed prices. But I think, as Everton mentioned, the key point is that we can't forget that maximizing feed efficiency and improving the key performance indicators will always deliver a cost benefit, but even more so during times of high feed prices.
And Rob, over to you.
Yeah, I think the only thing I would add there is our job as nutritionists are to try to get every possible bit of nutrients out of those ingredients. And times like this, when prices are high and availability is tight, it really challenges us to look at technologies, not only enzymes but others, to achieve those goals.
Yes, thank you, Rob. I think, like Everton mentioned, we really have not seen a situation like this before, or on this scale before, and it is presenting the industry with challenges that will require, like you said, us to look at our technologies and employ some innovative thinking. And of course, as you all have touched on, extracting the most that we can from feed ingredients is key. in the situations. And of course, enzymes are a valuable tool to do so. So with that, it is time for our first industry professional question. This one comes to us from Mingen Chopt, Professor of Animal Nutrition at the University of New England in Australia.
Thank you very much for your presentations. My question is, despite the well-known benefits of using enzymes in feed over the past 3 decades or so, there are people out there who will ask, why should they use enzymes in their feed in times of rising costs? So can you please share your views as to why such questions still remain and how best they can actually utilize feed additives such as enzymes, especially in times of rising costs? Thank you very much.
So Guillermo, what do you think? Why are there still so many enzyme non-believers, and how can we convince them otherwise?
Yeah, so this is a broad question from my point of view, since there are many enzyme categories in the feed industry, and phytase is already generally accepted by poultry and pig producers. So I'll try to focus on NSP enzymes. Indeed, commercial application of feed enzymes started in the late 1980s, and ever since a lot of progress has been made, but a lot of work is yet to be done, and there is still some, especially because there is still some reluctance on the application of fiber degrading enzymes, mainly because they are perceived as less predictable or less consistent when compared to phytase, for instance. In fact, the response to the NSP enzymes is usually variable, and the reasons for that are unclear because the exact modes of action have not been fully elucidated yet. In addition to that, one single NSP enzyme, like xylanase, for instance, can have numerous substrates with different complexities, which can lead to a variability in the real impact of the enzymes. And despite more than almost 4 years of research, the understanding of the underlying modes of action of NSP enzymes has not progressed as much as we hoped. And while phytase is commonplace in the feed industry and used in almost all poultry and pig diets, roughly 70% of the diets contain an NSP enzyme, according to recent market surveys. There has been a lot of development in terms of biotechnology, especially in fermentation and microbiological technology, which make feed enzymes affordable to poultry and pig producers from, I think, from all over the world. And it's clear that the use of NSP enzymes in the feed formulation can result in economic benefits. And these benefits usually increase, or in most cases increase, as the price of raw materials go up. As an example, a commercial broiler will consume roughly 0.5 grams of NSP enzyme from 1 to 6 weeks of age. If we consider a standard enzyme dosage of 100 grams per metric ton of feed, which represents an investment of only $0.75 per bird, which means less than 1 cent per bird, considering an enzyme price of $15 per kg or $1.5 per treated ton. In fattening pigs, the investment per animal is close to 37 cents. And now, if we consider the improvements in performance that we often observe with NSP enzymes, the cost per ton of gained body weight, or the cost with feed to produce 1 ton of body weight, can be reduced between $10 and $30. So if the nutritionist decides to apply an energy matrix to the NSP enzyme, which is often a common practice in the industry nowadays, even with conservative matrix values like 30 or 35 or 40 kcal of AME, of energy per kg, it's possible to reduce feed costs in view of these high feed prices. And taking into consideration what the enzyme can deliver, it's at least reasonable to say that NSP enzymes represent a great opportunity to help pig and poultry producers, especially because feed price fluctuations will continue to challenge our industry. And despite the reduction with feed costs obtained when an NSP enzyme is used, there are several good reasons to believe that NSP enzymes can be a useful tool to help poultry and pig producers. So I have a list here of some of these benefits. The first one is the variability. So variability is something that nutritionists must deal with, and today tools like NIR and other tools can help to attenuate that. Nonetheless, there is evidence showing that NSP enzymes can help to reduce the variability in the nutritional value of different raw material batches. The xylanates may have, for instance, greater effects in poor quality batches, increasing their nutritive value and ultimately reducing the variability between different raw material batches. How feed enzymes can enable the utilization of alternative raw materials, I think it's an area that needs much more investigation, but there is already indication that the use of exogenous enzymes can at least attenuate some of the deleterious effects of fibrous feedstuffs like rapeseed meal, sunflower meal, DDG, and so on. It's well known that NSP enzymes can also reduce digestive viscosity in broilers and pigs, which can ultimately improve the quality of the excreta or the feces. And by reducing the incidence of sticky droppings, so to say, the litter quality can be improved, and then the incidence of foot pad lesions is reduced. In piglets, we've also seen a reduction of diarrhea incidence with the use of feed enzymes, and this can be related not only to the viscosity reduction, but also to an improved intestinal health triggered by the inclusion of feed enzymes, including xylanase and phytase. And over the last few years, I think more evidence has been presented to suggest that NSP enzymes can break down the large non-starch polysaccharides, the NSP, into multiple fermentable oligosaccharides that have a prebiotic effect. And this is suggested to be one cause of the benefits of NSP enzymes like xylanase and mannanase, for instance, because this higher production of short-chain fatty acids can support better gut function and optimal performance. And the use of xylanase has recently shown to improve viability of growing pigs, for instance. And nevertheless, the mode of action has not been elucidated yet, but improvements in gut function and improved gut microbiome are possible explanations for that. And we also know that the use of antibiotics as growth promoters can at least attenuate the consequences of an excessive flow of nutrients into the hindgut by limiting the ability of pathogens to colonize the gut. And as the industry is currently making this transition to antibiotic-free systems, or at least to reduce the use of antibiotic, there is an increased opportunity for microbial overgrowth, which can potentially affect the intestinal health. Therefore, I think it's pivotal to control the amount of nutrients reaching the hindgut, and the feed enzymes, including not only phytase, but also NSP enzymes, can certainly support that. And last but not least, the fact that the animal can extract more nutrients from the diet when feed enzymes are added has the benefit of reducing the wastage from animal production systems, mainly through the reduction of phosphorus and nitrogen in runoff.
Thank you, Guilherme, for that in-depth explanation, and you made quite a strong case there for NSP enzymes, and I think you might have just changed some of those skeptical minds about them. And as you pointed out there, they can have some real impact on animal health and performance, and also, as you mentioned, the use of more alternative feed raw materials in feed. As we all know, more and more feed makers are turning to these materials to help mitigate the cost and availability of traditional ingredients. But what are the key factors that they should be considering in terms of their enzyme strategy when using these materials? Rob, can I throw this one to you first?
Sure. You know, alternative raw materials give a great opportunity to offset cost of the total diet. Of course, we've got to, beyond the enzyme idea, we have to look at their total nutrient value. We've got to take that in consideration. But particularly as it pertains to enzymes, we've got to be considerable of what are they going to contribute from a substrate perspective, such that the enzymes can actually be beneficial in improving the digestibility or improving the availability of the alternative raw material on the one hand, or if it happens to be a alternative that contains what we largely consider anti-nutritional factors that enzymes could break down, how much of those types of ANFs, if you will, are contained in, be it mannins at a high degree or something that the enzyme can further break down to help keep the animal in production.
And Everton, what do you think?
No, I agree with what Guilherme and Rob mentioned. The most important thing is to understand that enzymes are tools that degrade something which is not accessible by the regular digestive system of swine and poultry. So everything has to be connected to substrate. And then you have to know quite well what kind of raw materials you are using and what's the composition. As nutritionists, in general, we realize what's the nutritional composition. I think a nice exercise is to realize what's the non-nutritional or anti-nutritional composition, and based on that, seeing in establishing a rank of what is not accessible and how can I use enzymes in a good way to make it accessible to the animal. That's the key point.
Now, Guillermo, I know you've touched on this in your previous answer, but do you have some more thoughts on this that you would like to share with us?
Yeah, very quickly. So already mentioned by Rob and Everett on the composition, of course, but mainly in terms of fiber and phytate levels, I think, because most of the alternative raw materials have higher contents of phytate and fiber than the standard feedstuffs used in the industry like corn, wheat, and soybean meal. I think another factor is to anticipate the variability in terms of composition, because the batch-to-batch variation is especially high in alternative raw materials like DDGS, for instance, and this requires a more rigorous monitoring of the raw material quality in order to make the right use of the feed enzymes. And last but not least, the inclusion rate of this alternative raw material in the feed formulation, I think it's also crucial, because then we can determine the enzyme strategy in terms of which enzymes and the enzyme dose rates, especially in regard to phytates.
Thank you all for your thoughts on that. It's clear that with more and more of these alternative raw materials being looked at to replace traditional ingredients, the composition of these materials needs to be carefully considered when developing enzyme strategies. And of course, we've discussed NSP enzymes potentially being of help here. We've mentioned phytases a couple of times, the big one. But what are other enzymes that we should be looking at? And I think our next industry question touches on this a bit more. Here's Dr. Leanne Brooks, who is a nutritionist at Smithfield Foods.
These webinars often tell us about the impact phytases can have, but there are other enzymes we could use as well. What is the benefit of these other enzymes, and what research is there to demonstrate their effectiveness?
Everton, I think we'll let you take this one.
Great question. Look, we do survey here in our research center about cost production of swine and poultry, okay? And what we saw during the last 12 months was a huge rise in cost of raw materials. And actually, more than 75% of the cost production of a broiler is feed cost, and swine is almost 80%. And the raw materials, they almost doubled, or in some regions, they are more than doubled in terms of cost. Can you imagine the amount of cash flow money that the companies have to have in place right now to make their integration working as it should? So enzymes, for those guys that take decisions and to look to cash flow, enzymes, they are really fantastic tools, because the good thing of enzymes, beside all these additional aspects that Guilherme and Rob mentioned already, which is nice, is to reduce the amount of money that you have to send to the field in terms of in feed, and to reduce the cash flow. That's important for a manager, okay? And so If you use phytase, for example, yes, phytase is fantastic because you have more than 60%, or in average 60% of the phosphorus content of vegetable raw materials is not available. If you look to the cost of phosphorus as nutrient in the diet, is very significant. So phytase is fantastic. But now there are other opportunities. For example, NSP, as Guilherme mentioned already, NSP, they can promote several benefits. If you remove antibiotics, you can have an improvement in terms of gut health. You have a cage effect of this non-starch polysaccharides. If you break these polysaccharides, you can release nutrients, and you can also extract energy from these polysaccharides. The point is why people sometimes are concerned, or let's say not feeling well using combination of enzymes and so on. For me, it's connected to the ways that people do those studies and combine the enzymes. Okay, you have to look to have nice experimental designs in order to see the benefits, especially when you combine enzymes. Okay, the synergistic effect between enzymes. Okay, but no doubt enzymes work. If there is a substrate, you can extract benefit out. So ranking enzymes and opportunities, I would say number 2, just after phytase, would be NSP enzyme. Okay, you can extract 30, 40, 50 kilocalories out adding these NSP enzymes. Next one, maybe protease. Why not? Because if you look to a standard corn and soybean diet, almost 15% of the protein content of the corn is not available, digested, or at least poorly digested. So there is room for the enzyme. From soybean, 10% of the protein content is poorly digested, okay, which is still available for hydrolysis. Then manganese, why not? Because we know the effect of manganese in the digestive tract. So there is a whole bench of enzymes that you can combine, and that's something that will happen. It happens already in many companies. Combining, for example, phytase with NSP enzyme, and then with protease and so on. And that's a trend that we will see more and more in the next years. And I think there is no doubt that we can extract value out, and for many purposes, saving money, making our production more sustainable, healthier animals, and so on. So there are many reasons to do that.
Thank you so much for that, Everton. And I think you've actually touched on my next question, which is about how to best approach changing one's enzyme profile and what needs to be kept top of mind when using multiple enzymes. So if you don't mind, I think I'm going to get Rob and Guillermo to also weigh in this for us. Guillermo, can we kick off with you, please?
Yeah. So I think for me, it's clear that the target substrate of this enzyme or this enzyme profile must be present in the diet in significant amounts, but also accessible and potentially destroyed by the enzyme in vivo. And considering that today almost all feeds will contain phytase, sometimes even at higher doses than the usual 500 FTU per kg, and xylanase associated or not with other fiber degrading enzymes, I think it's crucial to understand the response on top of these other enzymes and how all the enzymes interact when added together to the diet. This is relevant because most data for feed enzymes suggest that the effect between 2 or more different enzymes is usually sub-additive. And because of that, we need to pay attention to the total matrix applied when working with a new enzyme profile on top of a standard diet already containing a background of phytase and xylanase, for instance. I think in general, it's this, and other important characteristics include the stability of these enzyme products during feed processing in premixes, as well as the stability under the gastrointestinal tract conditions.
And Rob, any thoughts that you have on this for us?
Yeah, I think from a very practical point of view, one of the things that producers, farmers need to think about, and it's a challenge we quite often get whenever raw materials decrease in price. Fat, for example, decreases in price or becomes more available. They say, well, let's just put more phytase in and take out these other enzymes to save cost. And I think it's really important that everyone understand each enzyme has a very specific job. It's working on a very specific substrate, and they're not replaceable. So a xylanase can't replace a phytase, a mannanase can't replace a xylanase, a protease can't replace a lipase, et cetera, et cetera. Each have their place, and especially as we get further and further into extracting every amount of nutrient that we can out of those ingredients, each one of those enzymes become more and more critical. And so it's real easy to want to save a little cost, but keep in mind that they're there to do a specific job.
Thank you all for that. So definitely some valuable points there to consider when looking at reworking enzyme profiles in formulations. And like Rob mentioned, we have to keep the specific actions in mind when looking to rework our enzyme strategies. Now I think I have one more industry professional question lined up for us, which comes to us from Francisco Carnino, Head of Animal Nutrition at JBS.
Hello, my name is Francisco Carnino. I am the responsible for Animal Nutrition Department in JBS, Ceará, Brazil, and I have a question for you. A lot of the research around feed enzymes seems to be in poultry, especially broilers. But how well that research translates into other species, and how could we apply them in everyday swine nutrition today? Thank you very much.
So Rob, what can you tell us about how the research done around enzymes translates into applications for swine?
Yeah, that's a great question, and something we get challenged with, not only when we look at using broiler data in swine, but also broiler data in turkeys or layers even as well. You know, as I mentioned in the introduction, I had the honor, the privilege to do some of the first matrix work for phytase in swine back when I was in grad school here in the US, and that's really great. What we have to consider is, of course, the amount of work that has to go into generating those types of data and the understanding of how the enzymes are working, and frankly, the cost. We have to take that in consideration. To run ileal cannulation in swine is a pretty expensive endeavor, not only really complicated endeavor with 24-hour collections and whatnot. Just like we see when we use pigs as models for humans, for neonates, we use piglets to help us gain insight into what it could mean to a human neonate child. We use broilers. They are a really good model for not only for swine, but for other poultry species as well. And we can generate a lot more data a lot faster, say from a very cost-effective perspective. What we know is that the data actually translates really well, generally speaking. It may not necessarily always be a one-to-one transfer. In the case of protein deposition, when we're talking about amino acid matrices and whatnot, because broilers and swine, for example, have relatively similar protein deposition rates on a body weight perspective, then those data tend to translate really well. Some of the energy data needs a little more consideration. We have to think about that. It's not exactly one-to-one transfer. But it gives us a good guide, and that's what we're looking for: is can we use this data that we've generated in broilers that allows us to generate a critical mass of data quicker? Can we extrapolate that and apply it quite easily into other species? And the answer is yes, unequivocally. We've been able to do that. It's also different, the one place where there maybe is a difference is as we start to talk more and more about the impacts of some of the anti-nutritional impacts, some of these substrates that cause problems that maybe engage the immune system. There we maybe see some differences, but and maybe there's some reason to do some species-specific work. But generally speaking, we can use the broiler as a great model. I did for all of my graduate work. I think Everton does the same at his university. It's a wonderful working model that gives us insight into not only swine but other species as well.
Thank you, Rob. Good to know that the data gleaned from work done with broilers can confidently be applied to swine and other species. And I think that brings us to the end of our webinar. But before we go, I would just like to ask our speakers if there are any final words that they would like to leave our audience with. Rob, can I come back to you for some final thoughts?
Yeah, I think as our audience sets to depart, first of all, thanks for joining today. But more importantly, again, I want to reiterate, each enzyme has a specific job. Plato said best that necessity was the mother of innovation. I think it's important to realize as we now have the necessity to get everything out of each kilo of raw material that we can, both from a doing what's best for the animal perspective and a sustainability perspective, but also from a cost and availability perspective, enzymes can be a great tool, and really encourage everyone to embrace looking at enzymes and using them every day.
Thank you so much, Rob. Everton, over to you. Any final thoughts, any last words you would like to leave our audience with?
Well, yes. First of all, I would like to thank for the opportunity to share with you some ideas and to have the opportunity to talk to everybody. If we look to animal protein production as a business, what's our commitment? What do we really want as producers? We want to produce safe and sustainable and cost-efficient proteins. If you look to enzymes, that's exactly what the enzymes are capable to do and to provide us, okay? The enzymes, they're really fantastic tools, and they should be used as much as possible in feed plants in order to make our business more sustainable and safe, considering animal welfare and so on. So that's really a fantastic tool, and I have no doubts that in future we will adopt more and more different enzymes, and honestly we don't know exactly what will come in terms of enzymes for the future. Okay, I mean, they are all them welcome because there is a lot of opportunity.
And finally, Guillermo, what are some of the thoughts that you would like to share with our audience? Some of your final thoughts.
Yeah, first of all, thank you for the opportunity. My final thoughts, I think animal production will probably continue facing major challenges in the future. And a trend that we will see is the incorporation of alternative ingredients in monogastric feed. This will continue to increase, in my opinion. And these changes will potentially lead to increased amounts of fiber, phytate, and undigested nutrients in the diet. And the feed enzymes may play a major role in the success of this nutritional strategy. So I think there will be many challenges along the way, but also new opportunities to overcome them. And finally, the development of new enzymes that can target different substrates or at least boost the effects of the existing feed enzymes we have, but also support gut health and improve sustainability is crucial to support an efficient animal production system.
Wonderful, some really great takeaways there. So thank you all for that. And thank you for sharing your expertise with us today and giving us such a great and in-depth overview of just how important a role enzymes can play in helping us navigate the raw material cost and availability issues that we are seeing. I think it has been enlightening to see just how changing the way that we think about their application can have some worthwhile impacts on feed production and also the cost of feed. So thank you all for sharing your thoughts with us. And for our audience, our panelists are still online and will continue to be so for another 10 minutes or so. So keep putting your questions to them if you have any questions. And thank you to everyone who tuned in today and contributed to the session. We hope that you found it interesting and that you tune into future webcasts from Feedinfo.